Good morning, good afternoon, everyone. Welcome to today's webinar titled Best Practices for Securing and Monitoring AWS Environments with IBM Security QRadar. My name is George Mina. I head up our technology alliances within IBM Security. And today we're going to be covering a few key items, some of the common challenges we're seeing as our clients migrate more of their workloads to AWS, and at the same time, the opportunities we see and best practices on how we're able to extend visibility and insights into those particular workloads. We're going to then go through some of the repeatable use cases we've heard from our joint clients. And at the tail end, we're going to go into a do and demo. So with that, I'm going to hand it over to my colleague.
Hi everyone, my name is Corinne Alpers. I'm an offering manager or product manager at IBM Security, working on QRadar Cloud Security. I primarily work on our cloud security use cases and our cloud deployments.
Hi, my name is Chris Collins. I'm a technical architect on the QRadar integrations team, as well as the technical lead for that development team. I've been working with QRadar and cloud integrations for quite some time now and have specializing in AWS.
Good day, I'm Roy Bray. I am a security architect on the QRadar product architecture team, and I have responsibilities for compliance, secure engineering, and cloud deployments.
All right, everyone. Today, I'll be quickly discussing the complexities that come with cloud deployments from a security standpoint, as well as giving some general best practices. Then I'll hand it off to our architects to go over our QRadar integrations and deployment models for AWS. But before I launch into common challenges with implementing security practices and tools for cloud deployments and AWS deployments, it's important to understand how the shift from dedicated infrastructure to using cloud services has changed our security priorities. So with a dedicated infrastructure, there's limited scalability in terms of responding to market demands. However, security was much more defined. We had a high trust, perimeter reliant way of viewing security, as everything within a clear network perimeter could be trusted and was enforced by a firewall. However, as many businesses have transitioned to cloud deployments, that high trust perimeter thinking is no longer sufficient. Now we must operate on a zero trust model where identity is infused throughout security in order to meet the dynamic nature of cloud. But with that comes additional complexity. We now have a lot of services communicating across clouds and a lot of data coming out that needs to be properly analyzed. So again, we shifted from that high trust, clear boundary with a network perimeter to now having clouds with their own services, security tooling, and data. So with that context set, we'll next discuss a few common challenges of establishing security tools and processes when it comes to cloud deployments. So first common challenge, managing disjointed security tools. So there are a lot of security and monitoring tools out there. And when deploying to a cloud environment like AWS, there are usually native services that you can use, yet few can be extended to other platforms. So whether you have a hybrid or multi-cloud deployment, piecing together several different environments and their respective monitoring tools introduces a lot more complexity, as you can imagine. In order to have real-time response to vulnerabilities and threats, you need a single pane of glass with visibility across all platforms. And secondly, that kind of ties into the second challenge, which is lack of visibility. So hardening your infrastructure becomes much more complex when applications are communicating across platforms. So on top of that, when tracking down vulnerabilities and having proper visibility across all those platforms becomes even more critical. So when trying to harden your infrastructure in a cloud deployment or in an AWS deployment, knowing which APIs are exposed and controls you have in place are key. Then we have establishing a unified approach to security across all platforms, which can make a lot of difficulties in your business. So this goes back to that first point about managing disjointed security tools, but can be expanded to an organizational level. So it's tricky to have a unified approach to security when it comes to cloud deployments and services, and it takes dedication to ensure that tools and practices align. Then lastly, we have compliance requirements, specifically identity and access management. So ensuring the correct users and machines have appropriate access to applications, to data, to systems becomes much more complex and more important in cloud deployments. So a certain provider solution might not work across the business stack or scale as needed. So especially in today's work from home environment, users need access to organizational applications and data from all different kinds of locations, and businesses need to authorize and deny these permissions as needed. Here's a quick chart just to quickly go over how much the cloud security world has changed. So as organizations have accelerated their journey to clouds or to AWS, more security capabilities will be delivered exclusively through the cloud. So previously we had 20% of SIM solutions that had capabilities that were delivered through the cloud, and now we've jumped up to 90%. So capabilities like log storage, analytics, or incident management now will be primarily delivered through the cloud. All right, so let's talk about best practices for cloud security. How do we secure AWS deployments? So one, you want to establish visibility. So a lot of the complexity of using and securing uh, cloud deployments really boils down to lacking proper visibility. In today's session, Chris and Rory will be taking you through how to best monitor and secure your AWS deployments and what AWS integrations we have with QRadar today. Secondly, you want to integrate and align your security tools. That's what I want you to walk away with today, understanding that you need a single pane of view and a platform level approach to security. So rather than securing platforms using separate tools, you can get the most visibility through integrating and aligning your security tools and processes. That way, when you want to scale or adopt a new service, you simply integrate it within your cloud strategy without having to adjust everything anytime you make a change. All right, and that's what we're going to be talking about today is IBM Security QRadar with AWS. So QRadar secures AWS with a single pane of glass, comprehensive insights, real-time security analytics, and prioritizing threats. So it's not only getting all the data from your AWS deployments, but really knowing how to analyze what actually is important to respond to, making sure you really understand what's happening in your infrastructure. But rather than me talking through it, we're going to pass it on to our architects to show you what we have today.
Thanks, Corinne. So QRadar already has lots of great built-in support for various AWS services and ingestion methods, which can really help you to increase the security visibility. So on the QRadar side, we have sort of two concepts we work with. We have protocols, which are ways of getting data in from other outside sources, and we have what are called DSMs that are meant for parsing or normalizing that data into the QRadar event model to help feed into existing rules, custom rules, and building blocks to help analyze that data in a more logical manner. So some of the protocols that we have for Amazon Web Services allow data to come in from things such as S3 buckets, CloudWatch logs, or AWS Kinesis, for example. Since most of the AWS services support these as destinations, this creates a lot of flexibility for being able to ingest data from AWS. Additionally, as other companies put data into the cloud, they often use the bucket or these Kinesis methods as ways of collecting data as well. So as you migrate traditional on-prem data into the cloud, we're ready to bring that data into QRadar in this new cloud native method rather than the older syslog or TLS syslog type ingestion methods as well. On the DSM side, we have existing modules available for services such as AWS Guard Duty, Security Hub, the newly launched AWS Network Firewall, and most importantly, AWS CloudTrail. So as you know, CloudTrail is a definitive record of what is going on in your AWS environment in general. This includes things such as user creations, password changes, policy changes, starting and stopping of virtual machines, all the things that you need to monitor in your environment. QRadar does come with a robust set of rules to begin with, but we also publish things that are called content packs. And these content packs are additional security content that are relative to certain segments or certain integrations. So QRadar on our X-Force App Exchange does have a security content pack for AWS CloudTrail that contains specific use cases and custom properties to normalize things out of the CloudTrail data that would not normally be part of a network event, but to be able to parse out things like the region, the account name, the action taken, and various other things that are going to be very useful for searching on, triggering rules, and analyzing this CloudTrail data. As mentioned before, if you do have additional data that we don't have a DSM for out of the box, QRadar does have the DSM editor, which is a visual way of normalizing data into our event model that has helpers such as XML parsers, JSON parsers, or regular regex to be able to extract that data out and get data out of additional AWS services that we don't currently have support for, custom applications that you may have, or other applications that have put data into AWS that you want to process. So this diagram here just shows some of the connections that we have within the AWS environment to be able to bring data in to QRadar. Here's a quick overview of some of the terminologies that we have around this. So CloudTrail, as mentioned, is the definitive audit record of everything that's happened. CloudWatch is another way of monitoring data. So we recommend for some of our ingestion methods using CloudWatch to make sure ingestion is working well on the QRadar side. Another differentiator that QRadar has over many other of the SIM solutions is that QRadar began as an NBAD or network behavior anomaly detection product and has a very rich flow history. And we managed to convert or bring that flow knowledge into the cloud platforms by taking VPC flow logs and the newly launched AWS Network Firewall service and its flow logs and transforming them into our flow pipeline where they can get better analyzed as what they really are, which is flows rather than events. And in that flow pipeline, things such as conversations, direction, network discovery, service discovery can be much better processed and also analyzed along with flow specific rules. So that's very much a QRadar differentiator. And we support that through various QRoC and QRadar installations. So it's supported by both our SaaS services and our traditional on-prem services. So as Rory will talk about in a little bit more detail, QRadar has a very, very strong deployment flexibility that allows us to collect this data if you're deployed within AWS, or if you're still on-prem but have services in AWS, or have a mixture of deployment options. So I'll hand this over to Rory to go over some of our deployment options.
As Chris was just mentioning, QRadar has the deployment flexibility to essentially join you on your journey to cloud. In this particular case, we're showing this would be an early phase of that journey where the primary QRadar deployment is on-premise or in a traditional data center, but you're doing collection from the cloud. And there are a couple ways to approach this depending on how far into the cloud your applications and services are. So as Chris mentioned, we've got the ability to collect from S3 and Kinesis in a number of methods, which means you can begin simply by collecting directly from your traditional data center using the public APIs of AWS to get your Flow and CloudWatch and CloudTrail data into your QRadar deployment. So there's no waiting essentially for having to stand up QRadar in AWS in order to integrate with it. In the case we're showing here, however, we've actually positioned event collectors in AWS. And that's in order to get close to the data collection points or into the regions where your applications and virtual machines are running and collecting data with QRadar. And one of the other advantages of doing this is that the data stream from an event collector to the remainder of the deployment is compressed. So we can get some egress cost efficiencies and things like that as well. Important to note that QRadar's cloud marketplace images in AWS support all the standard QRadar host types. So you can position event collectors, event and flow processors, consoles, data nodes, and app hosts in AWS or on-premise. And you can connect them regardless of their position, which region they're in, which data centers they are in on-prem. The QRadar deployment works very much the way it always has. So we can move to cloud in stages. We can move to cloud wholesale. We can start fresh. The flexibility options for deployments are very flexible. In terms of recommendations, we generally recommend keeping event processors and flow processors close to the console. And that has a lot to do with data transfer and the performance of search and reporting within QRadar. Having those processors close to the console means the console can respond more quickly when it has to pull data from those event processors for a search. It also helps a little bit with egress costs in that because the traffic between processors and console is influenced most by user activity, random searching activity, and things like that, the bandwidth between those components can be a little bit unpredictable. The bandwidth between an event collector and event processor, however, tends to be fairly steady and is based on the amount of data you're collecting. It helps that way with predictable costing and things like that to have your event collectors in the cloud. But again, it all depends on how far into the cloud journey you are. There's absolutely, we have the flexibility to put the consoles, processors, everything in the cloud, and perhaps even flip this image so that your primary deployment is cloud-based and you're doing a little bit of residual collection on-premise with event collectors in your traditional data center. Either pattern will work, and as I said, QRadar deployments can expand in terms of the number of virtual machines and regions as necessary. So if you have a global AWS deployment, for example, you have many regions, perhaps geographically dispersed, you could pick a central region for your console and processing, but then distribute your event collectors, around the world and connect back to the central console using any of AWS's networking capabilities, VPNs and Direct Connect, or even VPC peering. Another way in which QRadar is very powerful and flexible in terms of the journey to cloud is the data normalization and categorization that we do. So Chris mentioned how we have DSMs or device support modules for a variety of services, including AWS ones, as well as a lot of traditional on-prem appliances and services. And the one distinction with QRadar compared to many other log management or SIM products is that we do a normalization after ingesting. So we take data, regardless of its source, and we build a common representation of it. And this allows us to do correlation across disparate event sources and event types. And this is what allows us, for example, to normalize event fields with the new AWS Network Firewall in exactly the same way as we've done other firewalls from other vendors, traditional on-prem ones, or even with the CloudTrail and security event logs from things like security groups. So in this particular case, we're demonstrating an example of an offense built up from suspicious activity in the network, where it began actually with a more traditional product, a spam email detection from Trend Micro in this case, followed by launching of a command shell from a Word document, followed then by API activity that indicates a massive number of EC2 instances starting up, perhaps for crypto mining or something like that, and then something that looks suspiciously like data exfiltration from S3. And there's a couple things that allow us to put together these use cases in QRadar to span cloud and on-prem. The normalization and categorization is one of those things. And then the correlation rules within QRadar, the rules engine that allows us to do calculations and sequencing of events using those normalized fields. And then ultimately, the offense chaining. So an offense in QRadar is the actionable event created from a series of events and flows triggered by rules. And an offense is something that a SOC operator would actually take action upon or investigate. And it's a central point from which they can drill down to the source data. Offenses, the offense engine in QRadar will chain offenses. So what that means is that if individual correlation rules fire off on some of these small events like we've seen here, spam email detected and so forth, QRadar can link those together using various event information. Perhaps it's, the target of an original attack becomes a source address to the next attack or so on. And QRadar is intelligent enough to link those together and create an offense chain, which is kind of what we're seeing right here. That works just as well with a mix of cloud and traditional data sources as it did in the traditional data centers to begin with. So as you move into cloud, the rich use cases can follow you and give you this high visibility into suspicious activity that spans workstations, on-premise, cloud deployments, container deployments, and so forth. This particular example is actually something that we have created in a use case simulation tool that you can get from the Xforce App Exchange. It's called the Experience app. And if you have QRadar, you can download that and actually play this exact example to get a view of how the use cases are built and how the events and offenses are chained together. So again, the takeaway is QRadar can integrate richly across on-premise traditional data sources, new cloud data sources, and regardless of where you're doing your collection, this sort of alignment and offense chaining will work to give you rich security use cases. With that, I will now pass back to Corinne.
Thanks, Rory. All right, everyone. Next, we'll be going through the second best practice, which is integrating and aligning your security tools. So as mentioned, we want to move away from piecing together different platforms and their respective monitoring and security tools to having an integratable practice set in place with tools and processes that make it so when you adopt a new service, you don't have to change everything. So the use cases that QRadar in general cover are things like detecting cloud misconfigurations, securing SaaS cloud applications, and enhancing cloud visibility. And we have a lot of different cloud apps that cover these different use cases. But today we'll be exploring a new integration that is AWS specific that Chris Collins will be introducing us to.
Okay, thanks, Corinne. So today I'm just going to give a quick show of the new QRadar support for the new AWS Network Firewall. So QRadar is starting off as a network detection product. It has lots of great built-in rules and support for firewalls. So this is really a great use case for QRadar, along with the flow support that comes along with these. So to set this up on the QRadar side, you configure the AWS Network Firewall to log its both alert and flow logs to an S3 bucket. Once that's set up, we recommend that you create an SQS queue for tracking the arrival of the new files, which is Amazon's best practice for collecting data from a bucket. And then you would configure it on the QRadar side. So here's just a quick sample of this setup in QRadar. Now this test setup here is actually a test setup in AWS already. So one of the things that comes from having your deployment in AWS, or at least the event collector within an AWS environment, is that we get an additional benefit from security credentials, in that you can assign the permissions to the EC2 instance rather than having to use keys. So in this case here, you can see I'm actually using EC2 instance IAM role for my authentication. I don't have any keys set up here. So that's a huge advantage to having at least a point of presence in Amazon, but as mentioned before, is not required. And then we've set up which queue that the data contains the new file notifications, and then we've set up the flow processing. So in this case here, this machine is just all in one, so we're going to send our flows to ourself. If you're in QRoC and you would be using a data gateway, this would also be replaying back to the same host. But if you're in traditional QRadar, this could be the IP of a local flow processor in your on-premises environment, or it could be a flow processor in AWS as well. We also have the ability recently added to be able to test configurations to make sure that we have connectivity to the endpoints, that credentials are good. So this is a newly added function to QRadar as well. That's been very helpful for customers to be able to troubleshoot permissions issues with queues and network connectivity. Where we're in AWS here, there's really no expectation of connectivity issues, but certainly permissions could be problems. So I've already gone ahead and collected some of the data from the AWS Network Firewall. We can see here, since it is a firewall, it's the type of events you're probably expecting to see, which are firewall permits and denies. We have source and destination IPs, as well as ports. There's no usernames, as it's not a credentialed firewall, it's a network firewall. But within these data here, there's also some additional information that's specific to the AWS environment. So this is a JSON object, which is very easy to deal with. We've got timestamps, we've got availability zones in the name. We can also add some custom properties to be able to parse these out and search on them as well. So this has the region is up here. It's the availability zone from down below. We have the firewall name for our sample data. It's just called firewall, but in a real environment, this could say dev firewall, or have some sort of name that means something to the folks that configured it. And we also have the rule as well that was triggered as a result of this. So when you're trying to trace back which rule this is, you can look at the severity of it and trace it back to the original source. Now, another thing that's interesting here is that we also have the flow ID. So this flow ID from this firewall rule says that if you're looking for the flow that was caused, that was a result of this, came from this flow ID here. So as mentioned earlier, QRadar has a rich flow capability. So I've actually got the flow logs that come in from this configured to go over to the network activity tab. Now, when these come in, we do a little bit of transformations to these to take them from a textual JSON log and convert them into an IP fix record. So when we do that, we're actually going to take things like the source and destination ports, but also the source packets, dest packets, and bytes, as well as any TCP or ICMP flags, to be able to really transform those into a more flow native type of a record. So you can see some example data here from that same data set that the alerts came from, where we have packet times. Once again, this is replay data, so the dates are old, but we have IPs, ports, whether it was TCP, ICMP, UDP. The applications come from the INET port listing that's built into QRadar on the flow side. This also can feed into service discovery. So if you have service discovery enabled for QRadar, as these flows are observed, then as you see local resources, if they're talking back, then sometimes QRadar can use a service discovery method to infer that these services exist on these hosts. And then as assets are created, those services can get applied to those assets. So this can be a way to help discover services that should be running, or enumerate different things. We also have access here to, I don't have the TCP flag showing here, but if we go into one of these records, we can see here that we have flow was created. It was HTTP web. This was, I think, obviously HTTP was probably port 80 or 443. This was 8080, which is also still inferred to be 443. Destination flags is the TCP flag. So this had a reset and an ACK on it. So if you're going to look at multiple of these in a row, you would be able to see the full conversation from the initial connection all the way to the finalizing of the connection. And as mentioned before, when we were looking at the logs, we had a flow ID that was referenced on the network activity page. You can actually bring up the flow ID as well. So if you were doing some research into an alert, you could easily do a search on the flow ID that's in the event side and find the relative flows that were associated with it. So we also have rules specifically on the flow side that sort of feed into events and flows. So by having them processed this way on the flow side, QRadar does provide a lot of extra insight into it. Now, not every QRadar customer is initially licensed for flow. Some people starting out are doing only events. So we did make a setup on the parsing module for AWS Network Firewall that if you don't want to process flows as flows for the time being, you can simply choose an alternate configuration on the collection side. And rather than picking the network flow module, we just pick line by line, and this will send all alert and flow data into the event pipeline instead. So rather than seeing your flows in this method here, you will see them on the event tab, and they will say, net flow record. All of the same data as far as the source and destination IPs and ports will be there, but the packet data will be sort of nested within the payload. And if you want to create custom properties for looking at those, then that's certainly an option. But the data is much better suited in the network activity page. But we wanted to offer all of our customers the ability to see this data and use it as needed. So that's just a quick overview of the AWS Network Firewall service.
All right, thanks a lot, Chris. Really appreciate you taking us through that scenario, and I want to thank the team for taking the time today to share with you all what we're doing with respect to QRadar and embracing AWS native security services. As we mentioned up front, QRadar is now a paid listing on the AWS Marketplace, so we encourage you to check that out. And there's some additional resources here around content extensions and apps, some of which we showed a preview of today, and how we're delivering on the security outcomes. Finally, our website provides a bit more detail on what QRadar is doing with those AWS native services. So with that, we want to thank you for your time today and hope you have a great rest of the day.